Here, we look into the 3D visualization of photoelectric phenomenon, in which electrons are emitted from a material when it is exposed to light or some form of radiation. In this 3D setup, we have an evacuated glass tube containing the curved metallic plate connected to the negative terminal of a battery. A rod connected to the positive terminal of a battery. The rod is known as the collector and the curved plate the emitter. The voltmeter gives the measure of the positive voltage of the collector. Ammeter measures the photocurrent of the circuit. Press start for the light source. When light strikes the metallic plate, emits electrons. If the wavelength of the source is below the critical value, adjust the wavelength slider to visualize it. Here below 295 nanometers the apparatus emits photoelectrons. The current indicates flow of charges between the gap. The small negative potential allows the emitted electrons from the surface to travel to the collector. A typical IV plot for the photoelectric effect is shown here. Adjust the voltage slider to see how current varies in the circuit. From the IV plot the stopping potential is determined. Stopping potential or the maximum kinetic energy plot for different frequency gives the work function. The photoelectric effect provided strong experimental evidence for the quantization of energy and was a significant step in the development of quantum mechanics. It demonstrated that light behaves both as a wave and as a stream of particles, photons, depending on the context. The photoelectric effect has practical applications in devices such as photodiodes and solar cells, where it is used to convert light energy into electrical energy. It is also a fundamental concept in understanding the behavior of matter at the atomic and quantum levels. Select a surface to determine its cutoff wavelength and frequency. From its work function. Here are selected solved problems to better understand the photoelectric effect. Use the 3D graphics to complement the learning process. You can find this interactive 3D simulations at effectual.github.io and effectual.com. If you encourage interactive simulation development in 3D graphics, do consider to like and subscribe.